All right. Um, I'll go ahead and get started. I'm hoping you've had a chance to kind of look at all of this, which, as I was writing it down, I kind of forgot how much this was. um, so I'm hoping at class and over the last couple of days, maybe over the weekend or just recently, we had a chance to kind of look at all this stuff, kind of like all together, just so you have it. It's condensed somewhere, so you have a reference sheet as you're studying. So here's mine. This was done probably about 20 minutes. Okay. And this covers everything from 2.1 to 2.6. 2.1, that's all the way on the left on blue. That's dealing with mostly quadratics. I think we get the definition of a polynomial in that, but mostly it's just quadratics. We need to be able to find zeros of a quadratic form, right? That's this thing right here. By factoring the quadratic formula, checking with the calculator, we need to be able to find the vertex from that form, and then obviously actually using a calculator to check. We need to be able to deal with it in standard form. We need to be able to find the vertex. We need to be able to find the zeros, and we need to be able to move between them, which mostly just results in completing the square. 2.2, we talked about the leading coefficient test, the intermediate value theorem, and we actually talked a little bit about the definition of a polynomial, right? So degree and leading coefficient, that gives us 4 different possibilities, which is right here, okay? And the intermediate value theorem will help us graph those things. Okay, so finding zeros, using the leading coefficient test, and using the intermediate value theorem will help us graph. Sorry, my Siri keeps thinking I'm talking to it. So using leading coefficient test, finding the zeros, and using the intermediate value theorem, we should be able to graph most polynomials. Okay. 2.3, that is long and synthetic division. It's kind of hard to put that in notes, but that's what we're doing. Number 2.4. So sorry, I'm gonna scoot back to 2.3. 2.3 is that's going to be used in like 2.5. That's just kind of a preview of what we're doing. Okay, 2.4 is dealing with complex numbers, so I is equal to the square root of -1. Any complex number can be written as a plus bi, so a real number plus a real number times I. Complex zeros come in conjugate pairs, and then when you multiply a complex number by its conjugate, you get the difference of squares. Okay, 2.5, that's with the rational zero test. And then that's where the conjugate zeros come into play as well. The big thing there is that we can write any polynomial as a product of a bunch of linear terms, linear or quadratic terms. And that degree will tell us how many zeros we can actually find, whether it be complex or real. 2.6, rational functions, so that's the asymptote stuff, right? So vertical asymptotes, that's when the denominator is equal to 0. Horizontal asymptotes, we compare degrees, and then we have those 3 conditions, slant, and then holes, okay? So that's all stuff we just worked on, so I'm hoping that's a little bit fresher. Okay, so this is here. This will be at the start, so if you want to go back to it, you can go back to it. I'm just going to clean it up real quick. So let's go ahead and start. Just starting from the top. Okay. So this is the practice test that you guys had in class. I just want to make sure that we understand what's happening. Okay. So as you have questions, put them into the chat or email me or whatever, and I'll try and answer that as best as I can. And then just keep in mind when you ask it, there's about a 10-second delay. And that's 10 seconds before I can actually see, or you can hear me. Okay, so give me a second to read it, and then I'll usually come back to it. So number one, find the vertex and zeros of the following equation. Show all work. You can do this kind of any way you want. I didn't have any other directions here. Right, so I didn't say by completing the square. I didn't say by factoring. I didn't say by using the quadratic formula. I didn't say any of that. So it's up to you. All right, I'm going to use the completing the square because that's always going to work. Same with quadratic formula, that's always going to work. Factoring sometimes is a little bit harder, but it's just how it is. Okay, so completing the square, the first thing we're going to do is we're going to focus on these two terms in the box. I'm going to factor out the 10 from both of those. Also, don't worry about this equals 0. I don't know why it shows up in a question like that, but I just wanted this. Okay, then we actually complete the square. So x squared up top left. Those factors are x and x. Then we split this middle term into two equal parts. So then x and x are in these two boxes. So that means 1 and 1, right? X times 1 gives you x. X times 1 gives you x. So everything within that box is inside the parentheses. We have to complete the square by adding in this next term, which is the 1. Okay, so this gives us 10 times x squared plus 2x plus 1. And because we added that in... Am I muted? I don't think I'm muted. Got it. Okay. Because we added in the 1 inside, we actually added in 10. Right? So we have to have minus 80. And then we have to subtract 10 on the outside. Okay. Then in order to actually make this vertex form, okay, we have to factor this thing inside, which we already did here. Right, the factors of this are x plus 1 times x plus 1. So we have 10 times x plus 1 squared minus 90. And then this is in vertex form. So our vertex here is negative 1, negative 90. Okay. The zeros is just when you set that thing equal to 0. So 10 times x plus 1 squared minus 90 is equal to 0. So we add 90. Divide by 10. Take the square root. And then subtract 1. So we get x is equal to 3 minus 1, which is 2, and negative 3 minus 1, which is negative 4. Bunch of different ways to do it. Again, you could try and factor that. X squared plus 2x minus 8. I think we should be able to do that. And then we could also use the quadratic formula. We could also do negative b over 2a to find the vertex. A whole bunch of different options. Just know what you're doing. So whatever option you feel most comfortable with, I don't care for number 1. I just want you to be able to do it. Okay. Number 2, convert the following equation into vertex or standard form. That's what I just did above, so I'm not going to explain this as much. We're going to take the first two terms. We're going to factor out the 3. We're going to actually complete the square. So there's a 9 there. So this turns into 3 times x squared plus 6x plus 9 minus 21. Because we added 3 times 9 in, we also have to subtract 3 times 9. So we're subtracting 27. So then we get 3 times x plus 3 squared minus 48. So then our vertex is negative 3, negative 48. And then we're done. Okay. I'm hoping that these two are fairly easy. Okay, so completing the square, using the quadratic formula, finding zeros, using the vertex, all that stuff should be pretty straightforward. Those are just really two different things, and you have a whole bunch of different ways to find it. Okay, you can also, to check, you can graph these both on a calculator, and then do second trace 0 to find the zeros. Just follow the prompts, and second trace minimum or maximum, and then just follow the prompts. Okay, so you can check that on a calculator yourself. Number 3, graph the following by using the leading coefficient test, finding the zeros, and using the intermediate value theorem. Show all work. Okay, so this is just using the zeros and leading coefficient test and intermediate. So this is like 2.2 or 2.3 or whatever that lesson was. So I'm going to do this in different colors so we see what I'm actually doing. So the degree here is 3. That's odd. That gives us a general shape. The leading coefficient is negative 4. That's negative. So that gives us a direction. Okay, so that's the leading coefficient test. The zeros, we're going to set negative 4x cubed plus 4x squared plus 15x equal to 0. I'm going to factor out a negative 4 for, nope, I'm going to factor out a negative x from everything. Nope, not that. There we go. So negative x, what's left is 4x squared minus 4x minus 15 is equal to 0. I'm going to just use the quadratic formula for this. So negative b, so 4 plus or minus the square root of b squared minus 4a, so 16 times 15. Right, so negative b plus or minus the square root of b squared minus 4 times a, that's 16, times c. So there's really a negative 15 there, but that turns into a positive. I'm just simplifying as I go. All over 2a, so all over 8. Give me a second. So that's 4 plus or minus the square root of 256, all over 8. Rad 256, it's just 16. This is 4 plus or minus 16, all over 8. That's 20 over 8, and negative 12 over 8. So just to make this easier, this is 10 fourths, which is 5 halves. I hope I did that right. Yeah. And then this is negative 6 fourths, so negative 3 halves. All right. So those are our zeros. You can do that in a whole bunch of different ways. So that's the zeros for the inside. And then we have 0 as well, right? So we have negative x equals 0. That's obvious. And then we have 4x squared minus 4x minus 15 is equal to 0, which we did on the right. So that means x is equal to 5 halves, and x is equal to negative 3 halves. Great, we found the zeros. Okay, now what we need to do is we need to start to graph it. I'm leaving this open for you. I didn't want to give you kind of a set graph because some people get more confused with it, so I just left it up to you. Okay, so we have x equals 0. That's a point. That's a 0. 5 halves. So look right here. -3/2. Select right here. We know by the leading coefficient test that it starts up top on the left and then it goes on the bottom right. Okay, so far we have that graph, and then the rest we have to test in between, right? So I'm going to test f of -1. When we do that, so it's -4 times -1 cubed plus 4 times -1 squared plus 15 times -1. This is going to be a positive, so that's +4 plus 4 minus 15. This is negative. So that means that at -1, we get an answer that's negative. So our graph is going to come down below and then come back up to the 0. Okay, then we have to check in between the 0 and the 5/2. So let's choose 1. When we do that, we're going to get a positive number. So that comes up top, and then that's our graph. Okay, so degree and leading coefficient, so that actual like test, I think that's worth a total of 2 points. Finding the zeros, I think that's probably worth like 4. Testing is worth another 2, and then the actual graph all put together is worth like 3 or 4, if I remember right. Okay, so that's worth quite a bit. Number 4, find all of the real and or complex zeros of the function, hint, rational root theorem, and polynomial division. All right, so this is a lot. And I might actually decrease this test now that I'm looking at it. So if anything, this might be a little bit shorter, but that's okay. Find all of the real and complex zeros of the function. So I'm asking you to use the rational root theorem and then use division in order to find those. Okay, so the rational root theorem says that we have P over Q or R over P or P over R. I don't remember the variables that are used, but all I know is that it's the factors of the constant and the factors of the leading coefficient. So factors of the constant, that's plus or minus 2 and plus or minus 1. And then the same thing for the leading coefficient. So things that we need to test are really just plus or minus 2, I believe. And plus or minus 1/2. Okay, so what we would do is we'd plug one of those 2 things in, or one of those 4 things in. I'm going to do that on a calculator real quick. I'm going to mute myself because I'm about to cough, so hold on. Okay, I tested -2, so I plugged -2 into our function and I got 0. So that is one of our factors. We could also plug in others, but I want to show you the idea of this real quick. So this tells us that x plus 2 is a factor. Okay. So what we can do with this is we could divide this thing into our polynomial and then get another factor. And then we can do the same thing over and over again. I'm going to try and plug another one of these in and see what happens. So I'm going to try f of 2 as well, just to save us a little time. Okay, so I'm testing all of these. So this gives us x plus 2 is a factor, as well as x plus 1/2 is a factor. This turns out, so if we set this equal to 0, yeah, okay. I think what we could do is we could do 2x minus, or 2x plus 1. Because if we do that, we get negative 1/2. All right, so then that means this thing is a factor and this thing is a factor. Okay, what I'm going to do here is I'm going to multiply these two things together and then divide that into our polynomial in order to get the rest. So we get 2x squared plus x plus 4x, so plus 5x, and then plus 2. Okay, I'm hoping that that makes sense. All right, so what I'm going to do with this now is I'm going to divide that into our original polynomial. And I'm going to see if there's any other easy factors. Okay, so now we're doing long division. How many times is, I'll do this in different colors. How many times does 2x squared go into 2x to the 4th? That's 2x squared. So that gives us 2x to the 4th plus 10x cubed plus 4x squared. We're subtracting all of this. So we get negative 5x cubed plus 0x squared. Bring down the 5. And we rinse and repeat. And of course, this isn't going to go in well. All right. How many times does 2x squared go into negative 5x cubed? That's 5 halves. So negative 5 halves x. So we get negative 5x cubed minus 25 x squared over 2, and then minus 5x. So we get 25x over 2 plus 0x. Bring down the 2. And then we just rinse and repeat. Okay, so this is a horrible question. I'm not going to do this to you tomorrow, I promise. It'll be a similar type of question, but it's not going to be as tedious. So 2 into 25 halves. God. Hold on. Yeah, 25 over 4. I got there. That gives us 25x squared over 2 plus 125 over 4x. And then plus 25 halves. Yeah, I'm not going to do this to you. I'm going to make sure this works out a lot better. Okay, so what we would do then, we would have a remainder, so we actually can't do it. But what we would do is we would take this thing, we'd set that equal to 0, and we'd find the zeros of that. So we get 2 zeros. We get that 0 and that 0. by testing. Okay, normally what I'll expect doing, I will expect you to do, is I will expect you to find 1 0 by doing the this test, the rational root test. Divide that into the original polynomial, and then find the zeros of that thing. Okay, this is either I didn't do this right and I screwed up somewhere, or it's just not a fair question. Either way, I'm not going to put this. I'll make sure this is a little bit more well designed. So that'll hopefully kind of clear some stuff up. I realize that doesn't help at this point, but my bad for putting this on there. This is what you would get, but you're going to have a remainder, so you're going to have something over 2x squared plus 5x plus 2. So setting it equal to 0 is kind of tricky. It's not, I mean, you can do it, it's just not fair. There's just a lot there. Okay, so that'll be a little bit more better. So know how to use the rational root theorem, and then do long division, and you'll be able to find the rest of the zeros. On to number 5, graph each function by finding the vertical and horizontal or slant asymptotes, as well as any holes in the graph. Show all work. Okay, vertical asymptotes. Okay, vertical asymptotes happen when the denominator is 0, so x squared minus x minus 6 is equal to 0. Minus 3 plus 2, so x minus 3, x plus 2. Okay, that's just factoring that thing. So x equals 3, and x equals negative 2. So those are our two vertical asymptotes. So we get one right here, and we get one right here. Okay, so that's the vertical. Horizontal, we are comparing the degree of the numerator and denominator. The degree of the numerator, n, is 0. M, the degree of the denominator, is 2. So that means x, so y is going to be 0. Right, so n is less than m, therefore y is equal to 0. Okay, then we're going to test everywhere. And I would recommend testing the outsides first. So I'm going to test f of 3. When we do that, we get 4 over 9 minus 3 minus 6. I put that asymptote in the wrong place. It should be minus 3. No, wait, did I? Yeah, I did something wrong. Yeah, no, that should work. So we get x equals 3 and x equals negative 2. Oh, I know. I just put it on the wrong side of the dot. So x equals negative 3. So when I plug in x equals negative 3, f of negative 3, that's what I did. We get 4 divided by 9 plus 3 minus 6. So we get 4 over 6. That's above 0. So our asymptote is going to, or sorry, our graph is going to look like this. Okay, I test to the left. So let's plug in, God, I did this wrong again. That should be over here. F of negative 3. Negative 3 is on the left. Sorry, I'm butchering this entire thing. Why would you do 2x squared on 4 when it should just be x squared? Hold on to that, because that's a mess in and of itself. I'm just trying to pick up the pieces of how I screwed up this. Let me go back to that. So hold on, because I don't know exactly what you're asking. So let's finish number 5, and then we'll go back. All right, so we tested negative 3. That's right here. When we plug in negative 3, we get something above the asymptote, so everything is above. So let's go to the right now. So if we plug in f of 4, we get 4 over 16 minus 4, that's 12. 12 minus 6 is 6. So we get the same thing. That's above the vertical asymptote. So we get something that looks like this. Okay, so the rest should be easy. There's no special condition here, right? So now we test in between the two vertical asymptotes. So we plug in 0. When we plug in 0, we get 4 over negative 6. That's below the asymptote. Oh, yeah, that's below the asymptote. So we get something that looks like this. Okay. Okay, so that's number 5. I want to go back to number 4 real quick. Why would you do 2x squared on number 4? Answer should be x squared plus 1. Oh. Oh, yeah, that changes things. Yeah, okay. You're right. Yeah. Thank you. Good catch. I knew I screwed something up because I thought I wrote this so it actually does work. All right. 2x squared goes into 2x to the 4th. X squared times. Oh, God. When we do that, we get 2x to the 4th plus 5x cubed plus 2x squared. We subtract all of that. So we get 2x squared. 2x squared goes into 2x squared. So this whole thing goes into one time. Yeah, okay. So then we get 2x squared plus 5x plus 2. That whole thing is 0. There's no remainder. Okay. So then this is definitely a factor because we checked that. And then this up here now is a factor as well. Okay. So in order to find the rest of the zeros, we have to set that equal to 0. So x squared plus 1 equals 0. So x is equal to plus or minus I. So then we have all 4 factors. We have the x plus 2 factor, which we found by testing. We have the 2x plus 1 factor, which we found also by testing. And then we have x squared plus 1 we found by dividing the product of those two things into our original polynomial. Thank God we actually got there. Okay. Hi, Bryson. This is a horrible... Yeah, I've been really bad at this lately. Good catch, Graham. Great. So now number 6. we set our denominator equal to 0. So x is equal to 0 is one of our asymptotes. That just goes through the origin. Horizontal. N is equal to 2. M is equal to 1. Therefore, there's no horizontal, but there is a slant. Okay. So I'll do that in orange. So to find the slant, we divide 4x into x squared plus x minus 6. 4x goes into x squared 1/4 x times. So we get x squared. Bring down the x. 4x goes into x 1/4 times. And then nothing else matters. All we need, we don't need the remainder. So 1/4 x plus 1/4 is our asymptote. Okay, so 1/4 x plus 1/4, that goes about 1/4 above the origin. That's our y-intercept. And then we go up 1 over 4. So right about here, up 1 over 4. So right about here. Okay, so then that's our asymptote. Now all we need to do is we need to check. Okay, so let's plug in 1. When we do that, we get 1 plus 1 minus 6. It's negative 4. over 4 times 1. That's 4, so this is going to be negative 1. Negative 1 is like down here, right? So this is going to be below. Plug in negative 1. We get 1 minus 1, that's 0, minus 6. We get negative 6 up top over negative 4. So that's 6/4. That's like 1.5. That's like right here. That's definitely above. So then that's our graph. Okay. Number 7. Oh, there's another slant. No, there's going to be a hole. Okay. So number 7. I'm going to do what you really should be doing, which is factoring all this stuff first. So if we do this, factor an x out top, so we get x squared minus 9. On bottom, we can factor out 4x from both those things. So we get x plus 2. Okay, there's a common factor here of x. So x equals 0. There's going to be a hole. Right, there's a hole because there's a common factor of x on top and bottom. Okay. This also makes it really easy for us. So using the rest of this, we get x squared minus 9 over 4 times x plus 2. We can set this denominator equal to 0. And that'll give us our horizontal asymptote. So x equals negative 2, or sorry, vertical. Then we look at horizontal, which doesn't look like there is one. So n is equal to 2, m is equal to 1. You can do either one. You can start up here, or you can use these down here. I'm using x squared minus 9 over 4 times x plus 2. Okay. So n is 1 greater than m. So we have to check the slant. So I'm going to make this 4x plus 8 into x squared plus 0x minus 9. 4x goes into x squared at 1/4 x times. So we get x squared plus 2x. Subtract that, we get negative 2x. Bring down the 9. So minus 1/2. So up 1 over 4, up 1 over 4, down 1 over 4, down 1 over 4. So that's our slant. And then again, we just test. So if we plug in 0 into this function that we just made, that's going to be a hole. Never mind, we can't do that. Okay, so there's a hole at 0, which you can find where it's going to be. Yeah, okay. We'll plug in something else. Let's plug in negative 1. So negative 1 squared, we'll do the negative 1 cubed minus 9 times negative 1 over 4 times negative 1 squared plus 8 times negative 1. That's 1 plus 9, that's 10 over 4 minus 8, that's negative 4. Negative 10/4, that's just below 2, just below negative 2. which is like down here, right? So our graph is going to be like this, except there's going to be a hole at 0. So then that's the graph there. So then we can plug in like f of -3. So that's -3 squared minus 9 times -3 over 4 times -3 squared. That should be cubed. Plus 8 times -3. That changes things. All right, hold on. That should be cubed. Come on. So that's -1 plus 9. Which is 8. And then 4 minus 8. That's -4, so this is -2. It doesn't change much else though. It just changes the number you get. Okay, f of -3, do the same thing. So that's -3 cubed minus 9 times -3. And then 4 times -3 squared plus 8 times -3. Up top, we just get 0. So we get -27 plus 27, that's 0. Down bottom, it shouldn't matter. So 4 times 9, that's 36. Minus 8 times 3, that's again, it doesn't matter, we just get 0. So it's like right here. Okay, so our graph is up top. Okay, so that's the graph of number 7. That's a lot. I'm sorry, I messed up a ton. But all this is correct. I hope. I think so. Oh, rest is easy. Okay. Rationalize the following, show all your work. These should be really, really straightforward. For number 8, we have to multiply by rad 37 over rad 37. When you do that, you get 8 rad 37 plus 9 times rad 74 over just 37. And I'll take this. That's fine. For number 9, we have to multiply by the conjugate. So we have to multiply by -10 plus 8 rad 6 over -10 plus 8 rad 6. So we get -20 plus 16 rad 6 minus 30 rad 6 plus 24 times 6. I'll get that in a minute. And then over here we get 100 minus 64 times 6. Again, I'll get that here in a second. So we get, okay, so 24 times 6 minus 20. It's 144. Minus 14 rad 6. And then 100 minus 64 times 6. So you get -284. And that's their answer. The whole goal here is to get all the radicals out of the denominator. Okay, so number 10 is a lot like number 8, just dealing with an I. So we multiply by I over I. So we get 2I plus I squared over -7I squared, which is -1 plus 2I. Right, I squared is -1. Standard form says that thing's out front. Set -7I squared, that's just +7. This is our answer. Number 11 is a lot like number 9. We multiply by the conjugate of the bottom. So we do 5 plus 2I over 5 plus 2I. On top we get 20 plus 8I. On the bottom we get 25 minus 4i squared. So this is 20 plus 8i over 25 plus 4, which is 29. You can leave it like this. Really, your answer should be 20 over 29 plus 8 over 29i. This is technically standard form, but I will take that. Find a polynomial function with real coefficients that has the given zeros. There's a lot of different answers, okay? So we have different zeros. We have different factors, right? So we have x equals 0. We have x equals 2. And we have x is equal to 3i. Okay, so as factors, this says just x. That just stays still. X minus 2 and x minus 3i. Okay, so these are all factors of this polynomial that we're trying to write. Now, that last lesson that we did says that if x minus 3i is a factor, then x plus 3i is also a factor. Okay, and then any function is going to have some constant out front. Because I don't give you a point, you don't have to worry about it. So our answer would be f of x is equal to x times x minus 2 times x minus 3i times x plus 3i. This should be easy enough to do. We get x squared minus 2x. That's the first two terms multiplied together. And then we get x squared minus 9i squared, so plus 9. Then we can just multiply those two things together. So we get x to the fourth plus 9x squared. X to the fourth plus 9x. Yeah, okay. Minus 2x cubed minus 18x. And then that's our answer. Okay, that is one answer. You could throw a bunch of constants out front, but that'll do. And then to the one that seemed to cause Hudson Miller a ton of problems, and rightfully so. This x squared should be up top. I just typed it in wrong. That changes a bunch of stuff. And like the homework, I'm going to leave this up to you. Okay, this is the problem that I think I told you that would show up on the test. Okay, this should be relatively easy. How high is the pumpkin when it's launched? We're trying to find the vertex. Okay, what is the maximum height of the vertex? What is the maximum height of the pumpkin? Those are both the same question. Yeah, so one of these doesn't make sense to ask. This should say how far away is the pumpkin at its maximum. In other words, how far away from its launch point does it actually reach its full height? So that's negative b over 2a and all that stuff. Again, this x should be up top. I don't know why it's down bottom. I thought I checked that, and I guess I didn't. So again, this is finding the vertex and then finding the x value of that vertex, which both can be done in the same. I don't know why I split these two up, but that's okay. And then the last couple, these are multiple choice questions for a reason. I want you to be able to use your calculator. Okay, and I purposely made them so they're not imaginary numbers. I'm just trying to get you to use your calculator a little bit. Okay, so we could graph these. Second, trace, find the zeros, just follow the prompts. Okay, so I'm gonna leave these up to you guys. I might take away one or two. I'll probably take away one, just to make this a little bit more manageable. And I'll probably clean up this problem. And I'm definitely going to clean up this problem up here. But other than that, everything is the same. Okay, so that is the entire test. I realize I screwed up a bunch. Please let me know if you have questions. I'm going to leave this open and kind of slowly scroll through this. And if no one has questions in the next like 5 or so minutes, I'll shut it down. On number 4, I got x equals plus or minus I and -2 and -0.5 by using synthetic division again with the -0.5. That's fine. Those are all the correct answers. Um, so I tested to get x plus 2 as a factor, so x equals -2, right? So I using these things that we got from the rational zero test, I plugged -2 in first, and I determined that that's equal to 0. So -2 is a factor. In other words, x plus 2 is a factor. That gives us this. Okay, you could definitely divide x plus 2 into this polynomial in order to get another factor. What I did is I used the other term, -1/2, to get this factor. So I plugged in -1/2 and I got this factor. This is the same thing as this. Okay, I like 2x plus 1 better because it's neater. X plus 1/2 is 100% correct though. It's the same thing. So you are 100% right. Okay, because this is a lot of information, I want to open this up a little bit. Is there anything that you want me to go over that either doesn't make sense or could use some clarification? I can make a different problem as well. So, what do you want me to go over real quick that I can clear up for you? If there's nothing, then I'll just end it here. But again, I want to give you the opportunity because there's a lot here uh, to ask anything you need. Okay, in the meantime, I'm going to go up to here just because there's a lot and it looks good. You're welcome, Graham. All right, it doesn't seem like there's anything. So I'm going to close this down. Um, Again, this is going to be up for you in the next couple minutes. If you have questions, though, I'm going to try and be at school by my normal time, so 7:30 to 7:45 or so. If I'm not in my room when you come in, that's just give me a minute. Chances are I'm like printing your test. I'm also going to be there during activity period, which I believe is like right before your class. So if you have questions, like come in and ask, or you can email me, or you can reference this video. Okay. So good luck tomorrow, and I will see you then.